Okay, Algebra 2 students, let's finish up this part 3 of the review sheet. We have about, I think, 9 word problems to look at, so here we go. I'm going to pause this real quick and grab my calculator. Okay, students, here we go. Problem number 55. Two tow trucks here and here have attached cables to another truck that has gone through a guardrail. Okay, find the length of each tow truck's cable. Really, really, really simple word problem. Here's your right triangle right here, and looks like this height here will be 20, because that's that height there. As the wall goes up, it gets higher. It's higher over here. So this right triangle over here is going to come down and then come across this way and then back up this way. Hopefully you can see that right triangle. I'm going to make it a little easier to see off to the side here. It's 30 feet high, and this is 60 right here, so this is 60 feet. And we're trying to find this cable here. So in both cases, the cable is the hypotenuse. So we're looking for the hypotenuse here, and we're looking for the hypotenuse here. Guys, can you say Pythagorean Theorem? That's all that it is. Pythagorean Theorem all over again, just like geometry class. Alright, so here we go. The first equation would be leg squared plus leg squared equals hypotenuse squared. 20 times 20, 400. 50 times 50, 2500 equals h squared. 400 plus 2500, 2900. And then take the square root of both sides. The square root of 2900 would be 53.9. 53.9 if you round to that. Everything's in feet. So 53.9 feet. Alright, let's find the length of the other cable here. Looks like we have a leg 30 plus a leg 60 equals hypotenuse squared. 30 times 30, 900. 60 times 60, 3600. Add those two together, 4,500. Let's take the square root of 4,500. And we will get 67.1. So hopefully I've not made a mistake anywhere. So the length of one cable, where's the answers at? There we go, 53.9, 67.1. So let me erase all of this here. So the length of this cable right here is 53.9. The length of this cable right here is 67.1. Number 56. The end of the beam on the pickup is 6 feet above the ground. Find this height by solving this equation. Okay, fair enough. It's really not a word problem. They're just telling you to solve this equation. You know what I mean? So it's really not that difficult, but here we go. X negative 4 squared positive 18 squared equals 22 squared. Now, anytime you're solving an equation, if you can simplify first, do it, okay? I mean, it's so obvious to simplify first. I mean, let's make this easy, or easier. 18 squared, 324. Now I've got rid of that power. 22 squared, 484. Now, I'm going to take this right here and work on it down here. X minus 4 squared means you have x minus 4. X minus 4. So take your x here and multiply it through. X times x is x squared. X times negative 4 is negative 4x. Now take your negative 4 and multiply it through. Negative times the positive is negative. 4 times x is 4x. Negative times negative is positive. 4 times 4 is like terms, x squared, negative 8x, positive 16. So when you take x minus 4 squared, you get this right here. Alright, let's pick this up and we'll put that right up here. There we go. So simplifying really helps. Now that you've simplified, look at what you've got, guys. You've got a quadratic equation. Here's a squared variable. There's no other higher exponents, so we're good. I notice, unfortunately, I have an x term, so I will not be able to use the square root method. So I am going to have to use the the quadratic formula. Okay, so I've got positive 16, positive 324, and a negative 484. Using a calculator, I'm going to combine these three numbers here quickly. 16 plus 324 minus 484, negative 144. So I have x squared, negative 8x. When I combine these three numbers here, I got positive or negative 144. And on the right side, I'm left with 0. So here, 1 is right here. That's my A. Here's my B. Here's my C. Quadratic formula, negative B, and B is a negative 8, so negative 8 is a positive 8. Plus minus the square root of B squared. B is negative 8. Negative 8 squared is 64. Minus 4 AC. 1 times negative 144. Negative 144 all over 2a. 2 times 1 is 2. Now, under my radical here, I have 4. I have a negative 4 times a negative 144 is going to be a positive 576. I'll write that real small, 576. So I have a positive 64 and a positive 576. When I combine those, I'm going to get 620. So 8 plus minus the square root of 620 all over 2. Now normally we would not work with decimals, but in this problem here we are dealing with a word problem which we have to get out an exact number. So the square root of 620 is 24.899. I'm going to put 24.9. So now I have 8 plus minus 24.9 all over 2. Let's split that up. 8 plus 24.9 all over 2. 8 minus 24.9 all over 2. Well, let's see. 8 plus 24 plus 9 is 32.9 divided by 2 would give you 16.45. Over here, 8 minus 24.9 gives you a negative number, negative 16.9 over 2. We can stop right there because a negative over a positive will give you a what number? A negative, and we're dealing with what here is a distance. It's height. Height can never be negative, so we know this answer here is not going to be any good. So here's my answer. Let's pull that over here, get it out of the way. And I forget if we have the answer over here or not. Let's see if we do. We do not. Yeah, we do 16.6, so we rounded a little bit. We're off. If you rounded this to one place, you get 16.5. They're getting 16.6. Definitely close enough. Alright, so this is the height of x, 16.5. Alright, moving on. 57. From 1970 to 1990, the total amount spent on Medicaid is modeled by these two models. Okay? Notice M is the amount spent. It's in billions of dollars, and T is in time. Now, one is the federal amount paid, one's the state that's paid, the state amount. During which year was the federal government's share of Medicaid payments approximately 28 billion. Now, a couple things. We're going to do this two different ways. First of all, we're dealing with the federal government, so this is the this is what year will it be when it actually is. The cost of the federal government is $28 million. Now, let's do it the easy way first. Look at the graph, and we can estimate this. Millions of dollars, 28. So let's go, here's the federal, that's the one we want, it's federal, the blue line. So let's go up to 28, here's 10, 20, 30, so 28's about right there. So, let's draw a line going right through 28. That's about right there. Where does that cross the blue line at? Looks perfect right there at 4, 6, 8, 10, right there. So right here at this point, that point is on the blue line, is the federal. The federal graph is even with 28 and at 10. So I'm going to say about 1980 because 0 corresponds to 1970. So 10 would correspond to 1980. Alright. Now, I'm checking the answer here in the book to see if they have it anywhere. Not seeing it yet, but I will continue to look for it, or look it up in the back. But anyways, okay, they're saying 11, which is totally fine. 1981, because they're saying 28's a little higher, which would put about right here. Either way, we're just estimating. So that's one way to do it using the graph, okay? The more accurate way to do it, of course, is to solve the equation, okay? And so here we go. We want to find out the year when it's 28 billion, so we'll put a 28 here for M. We'll put a 28 here. And now we're going to have to use the quadratic formula. So we're going to have to get one side equal to 0, so bring the 28 over and make it negative. And we'd have negative 28 plus, bring the negative 28 over, make it negative. Negative 28 plus 5.8 gives us a negative 22.2. Now students, we have a lot of decimals, so for me I'm going to multiply everything by 100 to move the decimals 2 places. So multiply 0 by 100, multiply 0.13 by 100, multiply 0.58 by 100, and multiply 22.2 by 100. That'd be the decimal 2 places, so add 1 0. So 2,220. If you don't like this, don't do it, it's totally fine, okay? Alright, here's my A, my B, my C. So negative B plus minus the square root of 58 squared, 3,364 minus 4 AC, 13 times negative 2,220 gives us a negative 28,860. All over 2A. A is 13. 2 times 13, 26. Now, we have a negative times a negative here, which is a positive. Negative 4 times negative 28,860. So let's see what we get here real quick. Multiply those together. We will get a positive 115,440. So now I have a positive 3,364 and a positive 115,440. So if we add those two numbers together, we will get 118,804 all over 26. Now, because we're dealing with word problems, we need to get a number out. Let me take the square root of 118,804, and we're going to get 344.67, so 344.7. So 344.7 plus minus in front of that, negative 58, all over No, I said 2. That'd be a 26, wouldn't it? All over 26. Alright. Now, so we have negatives. Get some space here to work with real quick. Now we have a negative 58 plus 344.7 all over 26 and negative 58 minus 344.7 over 26. Now, this will give us a negative answer. So we're going to have to go less than 1970, and that's not possible. So we can't have a negative answer. Over here we have negative 58 plus 344.7, and we will get about 286.7 divided by 26. We'll get 11.02 or 11. So if 0 corresponds to 1970, then 11 would correspond to 1981. When I estimated my answer on the graph, I got 10, which was 1980. This is more accurate here. So the answer is 1981. Alright? Okay, moving on to number 58. Now, a review commission of the National Association of State Budget Officers projected. Now look. They projected the 1995 Medicaid spending by the federal government to be this much, and the state to be this much. Did they use these models or not? Well, let's see. Forget these formulas, we don't need them. For something like this, we can definitely use our graph and see if they're close or not. If they're close, we can assume they used these models that were just up here. Alright, so they're saying in 1995, now stop and think. 0 corresponds to what year? So 1995 would have to correspond to 25. So we're going over 25 on the x-axis. Let's start with the federal first, the blue line. Go over to 25. There's 25, now go up. It hits the graph right here at where? 100 billion. Okay? What was their projection for the federal government? 155 billion, not even close. So it doesn't look like they use these models. Let's check out the state government. The state government projection for 1995 was 67 billion. So here we go. Let's go over to 25. Now let's go up, and it's right here. Well, that's even with about where? 40, 50, so 40, 45. So on this graph, we're getting 45 billion, and they said 67 billion. So it's very obvious, just based on the graphs, the answer is no. They did not use these quadratic models back here. Remember these quadratic models right here? They did not use these quadratic models here, okay? Because they're not matching the graph. So it's obvious they did not. Okay, moving on to number 69, number 59. Okay, for 1970 to 1990, the population of Madagascar can be modeled by this formula, this function right here. Now, during which year was the population 874,000? Be careful. Notice P is already in thousands. Do you see that? P is already in thousands right here, guys, look. So when you go to put this in for P to find the year, do not use this whole number. Since it says it's in thousands, then you knock off the last 3 zeros for 1,000. And for P, you would put 874. Okay? I better do it down here. So do not put 8,740,000 in for P. Knock off 3 zeros. Put 8,740 in for P. And then that equals 6.4 t squared plus 135t plus 6,750. Alright, there we go. That's the model we're going to use. Okay, now we need a little more space. Let's get a little more space here. And here we go. Alright, let's first of all bring this over and make it a negative 8740. So we're left with 0 equals 6.4t squared plus 135t. And then 6750 minus 8740 gives us a negative 1990. And here we go, let's solve the equation. Negative b plus minus the square root of b squared. That would be 135 squared, 18,225. Negative 4 ac. A is 6. A is 6. And C is 1990. Negative 1990. So A positive, or A is 6.4. Let me do that again. So A negative positive times the negative is negative. 6.4 times 1990 is 12,736. And then all over 2A. 12.8. Alright. Now, negative times a negative. We can multiply these two together. It's going to give us 50,000 negative 4 times negative 12,736 is going to give us a positive 50,944. Alright. $50,944. Let's combine those two numbers and we'll get 69,169. Positive negative with the negative 135 all over 12.8. Now remember what we're trying to do. We're trying to find the year between 1970 and 1990. The population of Madagascar hit 8,740,000. Okay. Now, let's take the square root of this number, and we're going to get 263 exactly. So we have negative 135 plus minus 263 all over 12.8. Now, please, students, think with me, please. Okay. Think with me, please. I have a negative 135. If I use the negative sign, that gives me negative 135, negative 263. That gives me a negative 398. And a negative over a positive is going to give me a negative number. I don't want a negative number up here. There's no need. Look, we're dealing with a year. I'm not going to have a negative answer. So if I take negative and negative, that gives me a negative number up top. Divided by 12.8, because it's going to be a negative answer. I don't want that. So I'm not going to use the negative sign. Okay? But I am going to use the positive side. Negative 135 plus 263 is going to give me 128. So 128 over 12.8. So 128 divided by 12.8 will give me 10 exactly. So back to the problem. 0 corresponds with 1970. So 10, which is the answer I got over here, 10 would correspond with 1980. Alright, so there we go. Now, according to this model, when will the population reach this amount? So again, students, I'm trying to save you time as much as myself time. I'm not going to work this out. I mean, really, there's no need to. It's the exact same problem all over again. But I will say this. If you want to do it for practice, feel free to. But don't forget, when you're going to put this number in for P up here, it's P's already in thousands. So knock off your last 3 zeros. The only thing you would put here would be 16,560, okay? And you should get, it looks like, you'll get out 30 for your answer. So if 0 corresponds to 1970, then 30 would correspond to 20,000, alright? Okay, moving on to number 62 and 63. Madagascar has an area of about 226,660 square miles. The number of square miles in the rainforest from this year to this year can be modeled by this right here. What percent of Madagascar's area was rainforest? In 1955, what percent was rainforest? 1985. Now, guys, listen to me very carefully, please. It's asking for what percentage. So, we know the total square mileage in Madagascar is this. Okay? Look, if I said to you there's 20 people in the class, and what's the percentage of females? If there were 12 females, the percentage would be 12 over 20, and you would change that to a percentage, and you would get 0.6 or 60%. It's the same thing here. We're saying the total rainforest square mileage is this. So find how much area was rainforest in 55, put that number here, and then divide, and you'll get the percentage. In other words, you're taking the actual amount of square miles in 55 and you're putting it over all of the square miles in Madagascar to get your percentage. So we have to find the amount of square miles in 1955. So here we go. Okay, students, I paused the video because I was a little confused here on how this formula works. In other words, am I putting a number in for x? But now I see that it says right here, the number of square miles of rainforest in this year and this year can be found by doing what? Solving the equation. Okay? Solving the equation. So, let's solve this equation. And when we solve it, we'll get out how many answers? 2. And those two answers will be the number of square miles of rainforest in this year and this year. Okay? So, here we go. Let's get another page here. And x squared minus 96x plus 2048. Let's solve this. Negative b, and b is already negative 96, so negative is a positive 96, plus minus the square root of b squared. B is 96, so 96 squared is 9,216, minus 4ac. A is 1. 1 times 2048 is 2048, all over 2a. 2 times 1 is 2. Now, we have a negative sign here. Okay, I mean a positive sign here. Alright, so a negative times a positive is negative. 4 times 2048 would give us 8,192. So now we have 96 plus minus the square root of 9,216 minus 8,192. Alright? All over 2. Now if we combine these two numbers right here, we're going to get a positive 1,024. So 96 plus minus the square root of 1,024 all over 2. And the square root of 1,024 is 32 exactly. So 96 plus minus 32 all over 2. That would leave us with 96 plus 32 all over 2. 96 minus 32 all over 2. 96 plus 32 would be 128. Divided by 2 would give us 64. So there's one answer. 96 minus 32 would be 64. Divided by 2, which is 32. Now, there's our two answers. Let's go back and read here. It's in thousands. That's what I want to look at. So when you solve this equation, you're coming up with 64,000 and 32,000. Alright? 64,000 and 32,000. Now I'm assuming what they're trying to show us is that the area of the rainforest is decreasing. So let's find the so in 1955 it was this many. In 1955 it was this many square feet. This much square footage of Madagascar was rainforest, and now in 1985 it's down to 32,000. So let's find, sorry for yawning, let's find the percentage, okay? So here we go. The total square mileage is 226,660, so 64,000 over 226,600 would give us 0.2824, 0.2824. So round that to 0.28, and 0.28 is 28%. So we got the first one right, 28%. Now, let's take 32,000 over 226,600. Let's divide and see what we get. All right. We should get, let's see here. We're getting 0.14. 0.14 rounded, and 0.14 would be 14%. Okay. So that is the, those are the percentages. That's how much of Madagascar is the rainforest, okay? 28% of Madagascar is rainforest. Now it's down to 14%, okay? Now, the cross-section of a hill is modeled by a quadratic equation as shown in the diagram. How wide is the hill? How high is it? What is the volume? This is a great problem, and allow me to help you with the help video, okay? Here we go. Now here's the picture. It's cut off over here, but here it is. There's a picture now. Let's answer the questions carefully. How wide is the hill? Well, it starts here and goes to 500. I guess we're in feet, so how wide is it? 500 feet. How high is it? Well, let's see. The middle looks like it goes up to, I guess, 150. Looking at the graph, I guess we're supposed to assume. Actually, I don't think it goes all the way to the top, does it? Okay, unfortunately, guys, we're going to have to find the vertex. Because, listen, the vertex is over so far and then up so far. So the only way to find the vertex, the only way to find the height of this is to find the vertex. So here we go. How do you find the vertex of a quadratic equation? Negative b over 2a. Alright, so here we go. Here's my a, x squared, here's my b. So negative, up top is negative 0.0025 over, and that is incorrect, I apologize. Your b would be 1.25, and a would be 2 times 0.0025, which would give us, actually it's a negative, so 2 times negative 0.0025 gives us a negative 0.005. So this negative sign here comes over. 1.25 stays up top. In the denominator, it's negative 0.005. Alright, so I have a positive divided by a negative. Gives me a negative, plus I have another negative here. So my final number, when I simplify this, will be positive. 1.25 divided by 0.005 is 250. So I know I'm how far over 250. So I'm over 250. Now, how do I get the height? Well, remember, the vertex has two parts. You just found the x part. Now you gotta find the y part, or the height. So we take 250 and we substitute it back into the equation right here. So I have negative 0.0025 parentheses 250 squared plus 1.25 times x, which is 250. So remember, you first square the 250. So 250 squared is 62,500. So negative 0.0025 times 62,500, which would give us negative 156.25, and then plus 1.25 times 50 times 250 would give us 312.5. So combine these two numbers and you will get 156.25. So there's the height, 156.25. So we're over how far? 250, and we're up how high? 156.25. So your vertex is 250, comma 156.25. So the first question is, how wide is the hill? 250. How high is it? 156.25. Now, here's where it gets really, let me go ahead and write this in here. 156.25. Now here's where it gets really hard to understand, but hopefully you'll be able to understand this, okay? If I asked you to find the volume of a cylinder and it was laying on its side like this, you would pick the cylinder up and set it on its edge, set it on its end like that, okay? And then here's what you would do. You would find the area of the base. You'd find the area of the circle by using pi r squared. That's how you find the area of a circle. And then multiply it times the height, and that would give you the volume. Well, guys, picture this thing here. Picture that you walked over here to this side. Here's the other side you can't see over here. There's the other side right here. Pretend you picked this thing up and laid it flat on this face right here. Pretend you picked this thing up and laid it flat on this face right here. Okay, got it? Well, we could then take the area of that flat face right there and multiply it times the height, which is 500. Look at it again, guys, think about it. I took this cylinder, which was laying on the ground, and I tilted it up so that it looked like this. Then I found the area of this, multiply it times the height. Well, let's do that to this. Pretend you walked over here and you picked up this end and you tilted this thing up so that it's laying on this face. Now we could take, and if we did that, now the height of the thing would be 500 feet right here, right? Because this entire figure would be laying on this face here. So the height would be 500. So we could find the area of this shaded region and then multiply it times the height, just like we did here. Find the area of the base and multiply it times the height. So you're probably saying, Mr. Earhart, how do you find the area of this weird shape right here? Well, we learned it the other day, wasn't it? 1/2 a times b. Remember that? Okay, guys, I'm back. I actually paused the video to review to make sure I was right. And thankfully, I'm not taking the test on Friday because I would have had that formula wrong. It's 2/3 times the base times the height. That'll give you the area of this flat surface. Well, okay, we have 2/3. The base going across is 500. And we already saw that the height of this face go over, remember the vertex, go over 250 and then go up 156.25. So the height of this shaded area is 156.25. Alright, so here we go. I'm going to take 500 times 156.25, enter, and and then times 2/3. And I'm going to get 52,083 into third. So I'm just going to put 52,083. Now, that is the area of the flat surface. To find the volume, we're going to multiply it times the height of this entire thing, since we picked it up and laid it on this face right here. So take the area of the shaded area times the height, 500. And that will give you the volume. Now when I did that, I got 26,041,666.67. Their answer is 26 million. So they just rounded to the nearest million. Okay? And by the way, what are these answers here? Well, remember, they said how wide is it? 500. How high is it? 156.25. We found that right here in the vertex. And then what is the volume? 26 million. And we got this here. Okay? That's a really challenging problem, a good thinking problem. Okay, last but not least. One branch on a tree is 6 feet directly above another. I better draw that. Here's my tree. I don't try to get all fancy like this. Just draw lines and points. Here's your tree. Here's one branch. Here's the other branch. The height from here to here is 6 feet. Alright. A lemur's on the lower branch. Alright. So here's your lemur. I'm not even going to try. Y'all will laugh too much. I'll just put a point. There's the lemur. He jumps toward the higher branch with an initial velocity of 18 feet per second. Now stop. If they're talking velocity and stuff like that, we should realize right away we're dealing with our velocity formula. And you should know this for your test. Okay. Now the lemur's 18 inches tall. Will it reach the higher branch? Now, I'm surprised they included that fact that the lemur's 18 inches tall, because in previous word problems, they've not really been that picky about details like that, but that's fine. So let's really take our time and slow this down, okay? Now, they don't tell us how high the branch is off the ground, do they? No, they don't. So we're not going to worry about it. We're going to look at this like it's the ground. So that's your height of 0, and then from here to here, 0 feet, and then from here to here is 6 feet, okay? So h is your ending height. When you're all done, how far do you want the lemur to be up in the air? 6 feet above this branch. Alright. The question is, will it reach the higher branch? Well, the only way to know is to solve it and see if we get an answer. Now your velocity is going upward. Now remember, if it would have said the lemur threw himself down, then you would put a negative velocity. Okay, you put a negative number right here. But it says he jumped up. That's positive 18. Because his velocity is 18 feet per second. Now his starting height, or his initial height, is 18 inches. I guess they're telling us that because maybe if he reaches it with his head or his hands, he can hold on to it. I don't know, but the lemur's 18 inches tall. Remember, I taught you guys in this formula, your H's and your S's have to be in feet, your time has to be in seconds, and your velocity has to be in feet per second. So when it says 18 inches, you're going to have to put 1.5 in, because 18 inches is 1.5. And now, let's solve this and see what happens, okay? Let's bring this 6 over and make it a negative 6. So we have 0 equals negative 16t plus 18t minus 4.5. Alright, that should be t squared. So negative b, negative 18 plus minus the square root of b squared, which would give us 324 minus 4ac. negative 16, negative 4.5. Negative times a negative is positive. 16 times 4.5 is 72. All over 2a is negative 16, so negative 32. Now, inside the radical, we have a negative 4 times a positive 72. If you multiply those, you get a negative 288. So all of this right here became negative 288. So we have a positive 324 and a negative 288. And we're going to get, when we combine those two numbers, a positive 36. So I would have a negative 18 plus minus the square root of 36 all over negative 32. Now as the question is, will the lemur reach the higher branch? Well guys, look, the only way to really know is to solve this and see if we get out an answer. So the square root of 36 is 6. Negative 18 plus minus 6 all over negative 32. Okay? So now we have negative 18 plus 6. Give us a little room here. Negative 18 plus 6 all over negative 32. And we have negative 18 minus 6 all over negative 32. So yes, we are going to get out an answer. We would get negative 8 divided by negative 32.25 seconds. And then, let's see, negative 24 divided by negative 32.75 seconds. Now, which one is it? Well, remember, if he's on this branch here, and he jumps to this branch here, in reality, the graph would go up and then down again, okay? So, the faster time, 0.25 seconds, is when the lemur would reach that last branch, okay? The 0.75 is if it's kind of funny to think about, but if he jumped and missed, then on the way down, right here, he would hopefully catch the branch. That would be 0.75 seconds, but either way, the question was never, how long will it take? The question is simply, will the lemur reach the higher branch? In other words, does he have enough velocity? Did he jump high enough or hard enough? And the answer is yes, he did. Yes, because we're getting out an answer right here. So the answer is yes. I hope this third part of the review sheet help video has been helpful to you guys. If you have any questions, don't hesitate to call or